we have this evening is like, very, very, he is, as you can see here, he is in a hat as seen in the picture, but he is wearing not just this hat, he actually wears many hats. And the hats are of all kinds, and there are topies, and there are caps, and there are hats, and there are so many of them that I won't be able to speak about all of them. So his career profile is also um, very amazing, actually. A graduate in textile technology from IIT, he moved on to doing a post-graduation in management. Then he worked in the corporate sector for a few years. Then he moved on to help businesses to solve their problems, design solutions. And then he transitioned on to become an author. And he worked as the editor of a few magazines, two of which are very noteworthy. He is also a very strong human rights activist and an equally strong advocate for personal privacy protection. Just by the way, he is also known for his criticism of our Aadhaar biometric identification system. He is also associated with nature and wildlife and has done a lot of work on that. He is, however, more famously known for developing a software called as eLocutor for Stephen Hawking. Okay, all of us, I think, have heard about Stephen Hawking. So this happened after a chance meeting of him with Hawking when he came to Mumbai in 2001. So Hawking at that time had given some talks at the TIFR, and there was also a public lecture at Shanmukhananda Hall. So, sir, I don't know where you happened to meet him, but if you met him at Shanmukhananda Hall, I was also in the audience somewhere. So, and then with the help of a few other specialists from varying fields, they came out with this software which enables a severely disabled person to generate text and speech using a single button interface. So, and then Mr. Vickram went on to find an NGO called as BAPSI, BAPSI, Bi-Directional Access Promotion Society. That was in 2009. His the device that he developed for Stephen Hawking happened in the early 2000, and then he founded this NGO who works on making technology accessible as well as affordable for people with special abilities. He continues to work in this, and he continues to bring technology to specially able people. And while I am not capable of, I think, thinking what the obvious is in his today's title of Rethinking the Obvious, I think I will hand it over to Mr. Vickram Krishna to start with his talk and enlighten us all. Thank you so much, sir, for being here today.
Right, thank you. I'll just correct you on one small thing. BAPSI was created by my colleague, Dr. Arun Mehta. It's not me. I'm not involved with BAPSI directly, except that Arun and I collaborate on a lot of things together. So in that sense, I assist him with BAPSI. But BAPSI is his baby, and he's done a lot of this development in BAPSI. Okay, so that that's he's a really fantastic, among other things, computer programmer. So he's really good at that, and he's a wonderful teacher also. So yeah, so I just wanted to quickly run over the past because it's already been covered to some extent. The disability, special abilities related assistive technology. We did a lot of work in the early 2000s with low-cost community communication technologies, much of which was simple radio. From that, we use simple radio. Well, I actually use simple radio. This was outside of the work that, not directly connected with the work that Arun and I were doing together. Uh, this was something that we did in Bombay. I did a concert, very large concert. That's called the Banganga concert series. People in Bombay will be familiar with it. It's a huge water tank, one of the very oldest water tanks in this part of the world, um, where classical music concerts were held once a year. So instead of using a standard sound system, which by the way was a 5,000, 10,000 watt sound system, I used radio instead, and the receiving devices were radios which are distributed among the audience, and the total energy consumption was only 15 watts. So that was a phenomenal difference. And the big thing was there was no sound echo at all in that huge stone surrounded environment. There was no echo, and there was no spillover of sound to the area outside the water tank. So that was something to show people. The police were really interested because there was already a law in place that you're not supposed to be making a noise, which is very funny because we have the Ganpati festival going on right now. And the High Court has done absolutely nothing about preventing people from disturbing other people with that racket. Anyway, that's much of what happens. And there's nothing much one can do about it really, except to protest and show people that there are, better ways of doing things. In recent years, I've been interested in a universal phonetic script, which is called Nayana, which was developed together with TIFR, that is the Homi Bhabha Center for Science Education, where several of us worked and did this development of a script, which is a universal script. It's a phonetic script. And the thing about it is that it doesn't need to, um, the person who's reading it doesn't need to see a character in any particular orientation. Every character is unique and it doesn't matter the orientation. So they're extremely good for people with uh, various forms of dyslexia. And since it is a phonetic script, it can actually adapt to any standard script, whether it's English, Devanagari, whatever, Roman script, Devanagari script, so many other scripts there are in the world. And a lot of people have done work on scripts. But it's very interesting that you can actually use a phonetic script to transcribe any other script, and which makes any other script readable actually. So we've developed some apps also with the help of graduate students who used to come to Homi Bhabha Center for their summer internship. We've done apps which allow people to learn how to use Nayana. Very interesting, I think. So let's move on now to what this talk is about. So this talk, as you can see on the screen, you can see a photograph taken many thousands of years ago, which shows what happened after human beings discovered how to make fire, how to use tools, and then how to start moving about. It's not actually a photograph, you can guess. It's actually a cartoon from a comic series called The Flintstones, which is about cavemen people, cave people. And you can see the protagonist, Fred, is driving a vehicle which has a roller instead of a wheel. But people think that the wheel is absolutely central to the development of modern civilization, along with fire and tool making, of course. But the wheel is what made a big difference. And it's the first, you might say, very, very deliberately engineered uh, complex creation. And we don't know exactly when this happened, but probably about 12 to 15,000 years ago, when the early human beings, uh, distinct from hominids who came earlier, but early human beings spread down from the steppes of Northern Asia towards Europe and South Asia. And they originally moved with whatever was used at that time, which was horses and cattle and other heavy pulling creatures, would either be ridden directly or they would pull a sleigh behind them, and the sleigh would be sliding over the earth. And it would be extremely difficult to do that because the sleigh was not, because the earth was not designed for these sleighs, right? Earth is developed to the way it is, natural. And it was difficult to make those vehicles move. But when they put a wheel on them, when they decided, when they came across the idea of using a wheel, it made their movement much, much easier. So that is, considered to be quite a change. But what happened after that? Thousands of years later, a very big, powerful empire grew up in southern Europe, and they were probably the first empire to actually develop by using trade as a way of consolidating their conquest. So they didn't just go across to other places and pillage as a normal thing done up till then. They actually established centers across a large part of the world, including India. They came to India also. And they were able to, they made a big difference in the way they conducted war. What they did was, instead of going to a battlefield, building heavy weapons, and then using those heavy weapons in the battle, they made the weapons in one central place and they carried them using wheeled vehicles to the battleground. And this changed the way that battles were fought. This was a huge difference. It actually enabled them to carry heavy weapons to the battlefield. So they were able to choose the battlefield, they were able to dictate terms on the battlefield, and they usually won. That was a big difference. And to do that, here's the thing, to do that, they created the first metalled or paved roads. They needed level roads for those heavy vehicles. So they actually created heavy roads, heavy load bearing roads, and they started building these roads all over their known empire, which covered basically southern Europe and Central Asia, uh, well, the western part of Central Asia at that time. Quite a large empire it was. So this was a big difference, and these roads have become, together with the wheel, they have become a very, very central part of our civilization. We can't imagine modern civilization without wheels and roads. So this was why I titled this talk Rethinking the Obvious, because everybody thinks that this is obvious. You must have wheels and you must have roads. It's obvious, but perhaps that needs a rethink. Because what do roads do? Roads interfere with the flow of water. They also interfere with the flow of land. That is, land is not a static object. It's not a hard, solid object. It's actually a flowing object. It flows all over the world. There are many places where land flows have been actually documented. And when you build a road across it, it interferes with that because a road is like a giant, very small, maybe about uh, 3 to 4 meters of mountain, a solid rock, okay, but a rock which is spread across the landscape, and it interferes with the flow of water and land. And of course, to make a road usable across most of the world, you also have to clear forests. So you're interfering with the ecology of uh, of the whole earth. And you can see this in many, many places. In fact, just recently, we had a terrible disaster in Jammu. These things happen. Before that, we've had disasters in Uttarkashi, where roads have been built on fragile mountains, and they cause immense ecological problems. This is a reality. So, what is the alternative to wheels? Because if you look around us, all the other beings on Earth, either they use wings or they use legs. So the initial thought of runners and skis, which were the sleighs of old time, and where you still find in snowy countries, people use sleighed vehicles. They don't use wheels to run over the snow. So that is still done. The second thing that is done is that can be done is legs. All the animals use legs. It's only human beings who have not made machines that actually duplicate legs. There are some machines, and I'll just describe them. These are these are the perhaps the most well-known machines of today. The first is the Strand Beast. This is an art project in uh, the Netherlands, which has been led by a very charismatic guy called Theo Jansen. He has been working on this project for about 20, 25 years, and he makes many, many creatures, I'll call them creatures, because they're autonomous, they don't use any electronics, they are just using the power of wind and legs, basically. So they do things like walk down the beach, go to the water, sip the water, and come back to the high ground on soft sand. They don't have wheels. They just have legs which walk on the thing. Cyberdyne assistive devices is a project from Japan. It's really another absolutely mind-blowing set of assistive devices. They actually make what we call exoskeletons. So you can fit an exoskeleton to a person and who's lost the use of either because of a spinal damage or some other kind of problem, can't use the legs, then this device will do the walking. So they also, help do sitting. So a person can sit up if it doesn't have use of hands. Then the Cyberdyne device will allow, can be controlled by thinking. Okay, so the person thinks and says, "Move my hand to the table, pick up the cup, and bring it to my lips," and the device will do it for him using or her using assistance to the actual hand. So these are really like hands and legs for personal use. And then there are the Boston Dynamics devices, which was another fantastic project which started maybe 20 years ago. As the name says, it's in the United States. Um, Unfortunately, as I've seen of late, Boston Dynamics has moved, perhaps because of the funding they get. It's a heavily funded venture capital supported company. Um, they make more like weapons than useful devices. They're not really aimed anymore at making useful devices, but they did start off with that they would make useful devices. So that's the history. What we have done, again, it's a project which started in the Homi Baba Center through the Knowledge Project. That's knowledge with the G, GNOWLEDGE. This is the Chalopede project. We call it Chalopede because Chalo means go in many Indian languages, and Pede means legs. So these are legs to go. So we're looking at many different things, which are briefly explained here on the screen. Individual activated design and technologies. We've looked at lots of things. The basic pistons. Now here again, let's go back in history a little bit. The concept of a leg that does what a wheel does goes back to around like Pythagoras, the Greek philosopher and engineer, you might say. Well, he was a very multifaceted person um, who understood that if you want to draw a circle, then you just need two straight lines, and the locus of the circle is those two straight lines, moving at right angles from their center. That creates a circle. Archimedes afterwards invented a different device. He invented a device which we still use in engineering school. We use it as a drawing tool. It's called the trammel of Archimedes, and it allows you to take two, movements at right angles to draw an ellipse. So basically, these are concepts which are so basic, so well known for thousands of years, but we don't actually use them very often. Even Theo Jansen doesn't actually use those principles for making his legs. But what Theo Jansen has done, he's done something tremendous. He used a lot of calculation and came up with the most efficient shape that needs to be traversed in order for a leg to use the minimum amount of energy to move a certain distance. So when the leg comes down on the ground, it moves flat for a certain distance. So the vehicle above it is moving in the other direction. Obviously, the leg is moving back, the vehicle is moving forward. The leg is not moving at all, actually, because it's on the ground. It's fixed on the ground. It's, the point that's touching the ground remains exactly where it is. It's not rolling on the ground. It is just staying on the ground. And then it lifts up and comes back with the most efficient use of energy to lift up and move forward to the next step. So that's something that Theo Jansen has done, and he's made it freely available. So next point is combined integration of activators. If you use multiple activators, if we call each chalopede an activator, we call it a foot or call it a toe, then you use multiple of them and you get an extremely smooth device, a smooth moving device. You can't tell the difference between a device using legs and a device using wheels. If they were both moving on level ground, you wouldn't know the difference. The platform which they are supporting would be completely level, the same level as the ground. But here's the interesting thing. If the ground was uneven, the platform would still move in an even direction because you're controlling the movement of the leg through simple mechanics, simple mechanical design. You don't need computers, you don't need anything else. Your simple mechanical design makes sure that the platform stays level no matter that the ground is uneven. Except when you're actually climbing, of course, the platform will be also elevated at some angle. But that's, that, right? When you're climbing a hill, obviously you have to make make some provision for that. So you'd put, say, you'd put something at the back of the vehicle so that anything that's in the vehicle wouldn't fall off it. A fence, right? Or a seat back or something like that, whatever, depends on what you're using the vehicle for. Then the vehicle direction and velocity control, these are things that it's so simple. If you've got a spread of actuators across traversing the vehicle, then to turn, all you need to do is the outer side needs to move faster and the inner side needs to move slower, and the vehicle will turn. That's all there is. There is no slippage at all. Slip is one of the biggest problems for wheeled vehicles. It causes tire wear. It causes tire wear. The rubber actually rubs off on the road. It gets abraded, and that's the reason that car tires wear out faster than they should, because when the vehicle is turning, the tires are trying to go straight, except the front wheels where you actually physically turn things. For those, you have to make other complicated calculations. The vehicle which is turning on four wheels, the outer front wheel is moving a different distance than the inner front wheel. So you have to make a complicated adjustment so that the outer wheel moves faster than the inner wheel. In a chalopede, this is not an issue at all. You just move the side which is on the outside, you just move the legs faster. And on the inside, you just move the legs slower. And that's turning. And instead of having the front wheels do that control, you have every wheel doing that. There's no wheel, of course, they're legs. Every leg is doing the control. So there is no issue at all. You're using a complete platform which is completely easily controlled. At the same time, if you change the rate at which these legs are moving, then you have velocity control for the vehicle and direction, of course. So velocity is both speed and direction. So you can move it backwards or forwards and turn with very, very simple mechanical controls. So what we've looked at in the project is what will we do? This is the interesting thing. Such devices can actually be made with simple materials like wood. Okay, so wooden rods could do it, or um, bamboo rods, something that is freely available in many places around the world. So instead of having centralized factories, you can actually put together these chalupeeds in a small workshop. That's all you need, a small workshop actually, just to do a little bit of slightly accurate work. So because you're doing everything at small workshops which are highly distributed, you can also ensure that the designs that you create are meant only for use in the immediate area. So every area in the world is different actually. The topology is different. The local needs of the people are different. Uh, there's no need to have a centralized production system or design system. You allow people in local areas to do what they want to do. So there's a not only hyperlocal assembly, there's hyperlocal sale. And because the designs are distributed evenly across the world on open source basis, so that anyone is free to use them, and to when they use them and when they develop their local designs, they publish them again so that other people who have the same need identified in a different part of the world can do the same thing without any disturbance. So to imagine an economic system which allows this, you can just think about it. It will just transform the way that industry works and that the uh, economy works. It just doesn't need to be the way things are today, which we can see all around the world. Like the tariffs kicked in yesterday, they create some kind of problems. So with that, that's, I think, basically what I've came here to talk about. And we've taken about 40 minutes, except for the time it took me to get the screen running. I apologize for that. Can we now switch to question and answer? Is that okay with you guys?
Yes, sir. Yes, sir. So, thank you so much, sir, for the talk. And can we have any questions now, please?
Can we see a picture of the device? Is it there?
Um, no, not of the device. This is a single actuator. You see the apex point at the bottom. That is the vertex at the bottom. That's the one which goes up and down absolutely vertically. This is a mechanism that was designed hundreds of years ago, but is documented in a book that was published 150 years ago. And now, online, you can find out, people have already converted these into animated drawings. So you can actually find out how to make one freely available. It's a absolutely simple design. It's different from the one Theo Jansen uses. He's got a different design, but then his objective is different and Chalupeed's objective is different.
Okay, thank you.
I think I'm missing something. Maybe these chalupeeds are meant to be vehicles for individuals, or it could be used as equipment for any kind of activity.
According to me, a Chalopede could do anything that a bicycle does. It could also do anything that, say, for instance, a tractor does in a field. It just depends on how big you make it and what, special purpose gadgets you attach to it. But bicycle is, of course, the simplest thing that you can do with the Chalopede. Well, you could do a monocycle, but bicycles are much easier to run. Now, the wonderful thing about this is, since every local leg will have at least 4 pieces in my mind, okay, that's the way I've thought about it, 4 pieces side by side, the width of a wheel will be closer to that of a car than of a bicycle, which means the balancing on a Chalopede bicycle is much, much easier than balancing on a rubber-tired cycle.
So would this be a framework on which somebody could sit?
Yes, yes, yes. You have a frame. You have two-part framework. One is the lower part, which is the which is the part which is actually closest to the ground, which is holding the legs, and the legs go down and touch the ground in turn, in sequence. And then you have the upper part where the person who, if there's a person, is because it could also be used for a cart, so you could push a cart along. Um, if a person is sitting in it and using, say, the feet to pedal it or hands to make the legs move, the legs of the chalopid, not the legs of the human being. If you're using that, like you can just have like joysticks which you move back and forth, and then the vehicle moves.
How does it overcome the rough roads in our country? I mean, if it's to be like
There
a
are no
vehicle,
roads. It doesn't need a road. It can run. It can run on a rough any part where you don't actually have trees or something else interfering with your movement.
you mean to say even right on grass or rubble or anything?
Yes, 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 absolutely. Rubble or rough countryside or whatever. It can climb the 8-wheeled vehicle is doing on Mars. It can climb rough hills and come down rough hills.
So the material with which it is made would be important to take care of these different terrains.
Totally, totally. It just depends on what the local need is and what your local terrain is also. If you're living in a desert, so your local terrain is mostly sand with some rock, then you would use a material which is suitable for that and a design which is suitable for that. If you're using it for fields to do agriculture, for planting and things like that, then you would make a different design.
So has this been tried out with, say, metal or wood or plastic or whatever, so that
Actually built
different
one.
aspects have been, addressed?
So we have, as I said, we haven't actually built one. There is no real project at the moment. These are just people talking and developing ideas and looking at what can be done. And who knows, one day we might actually have a project put together that actually builds several kinds of vehicles and then takes them out. We have that in place. We have the ability to go to villages and offer local workshops the opportunity to make these things locally and to add to the design, to take ideas from local people as to what they need and make a vehicle that does that accordingly.
Okay, just to give us some ideas here. I mean, I don't have something to say, but what kind of a vehicle or a usable item could be made from it? Can you give us some thoughts on it?
Well, I've already said it. You could make a bicycle. Everybody needs bicycles.
Yeah, besides the
Bicycles
bicycle.
today, run very well on roads. They're not so good on rough ground. Okay, you have to have very, very special bicycles to run on rough ground. Whereas this vehicle, start with, can run equally well on a rough ground or a road. So start with the bicycle and take it to any level. It just depends on how big you build one and how many legs you put on it. Uh, I was thinking, like you start with 16 legs and you have each leg has got 4 feet, right? So that's 16 into 4. You start with that and you have a platform which can move on any surface. What you do with it above, that you can decide what you want to do. You want to move goods, or you want to carry people, you want to make a bus, you want to make a small car. That's all options. You want to use mechanical assist, you want to use the people to do to drive it themselves with their own human power. That's okay. I see a written question here. How is it different from a strand? The strand beast is an art project. It was designed to demonstrate that it was designed to make people think. We are so, we take so much for granted that we don't think. Theo Jansen wants people to think that when he makes a strand beast, which means a beach creature, it means sand creature. Strands are the sands closest to the sea, like a beach. And that a creature which can walk on that, go down to the water, come back, using wind power, uh, using any form of power. He uses water buckets, do interesting things. There's so many ideas. He's a very fascinating guy. The point is that he makes people think and to have new ideas about what is motive power and where is that motive power coming from. So how much it costs depends on what the configuration is and what you want to do with it. Like a bicycle would be really cheap. If it would certainly be cheaper than some of the bicycles you get in shops. No, it won't be very expensive.
So there is also a question in the chat box about can we use this to climb stairs? Can that be done?
Right. Sorry, I did not address that. That was one of the things that actually got us started on this project many years ago at Homi Baba when we used to meet frequently over there. Unfortunately, none of us today associated with Homi Baba, but it's a wonderful institution, as you know. Yeah, so climbing stairs is a very, very important end use. But when you think of it, stairs are also, there's no standardization of design of stairs. So many kinds of vehicles that have been used in the past, designed in the past to climb stairs, they work on one set of stairs and they don't work on another. Because when you say stairs, you're thinking of some kind of standardized design, but actually stairs don't have a standardized design. You're talking about, dwell of maybe about 15 centimeters to 20 centimeters. At 25, it becomes quite difficult to even climb it steps, right? But I have climbed, hillsides where steps have been put in, where each step was well over 30 centimeters, 40 centimeters, really difficult to climb. So you can just imagine making a vehicle for that would also be quite difficult. But on the other hand, if you did make a vehicle, for instance, for those special places, many of them are pilgrimage spots, you would suddenly make it possible for anybody to get up that hillside. What will what? What is the question?
Will it be very expensive one, which is already answered, sir? And what will it be easy to carry or move from one place to another?
Easy to what?
Easy to carry or move from one place to another.
Well, I think, yeah, well, that depends on what you're using as a motive power, right? So if you're using your own power like a bicycle, then it's just up to how much energy you have, no? And you can use to bicycle. There are people who bicycle all over India, so it's really not, that's not really an issue. I mean, I know people who bicycled all over India, so it's really not very difficult. I have a friend who bicycled from Goa to Kathmandu, so
Oh.
that's
Mhm.
pretty
So
easy
there
to
is
do.
one more. There is one more question. If it has 16 legs, won't that be hard to maintain? If it has 16
Well,
legs,
one thing
how
is with
to
16
maintain?
legs, yeah, just think about this. Yeah, think about it. Uh, I mean, there's a related question here is about tires. Okay, so is it hard to maintain? You know what? Even car leg wheels are hard to maintain actually. Okay, and they're very, very complex mechanisms. They have to have brakes, they have to have this, that, and the other. Legs don't need brakes. Okay, you just slow down and that's the brake.
Mhm.
Big difference. Um, the other thing is that it's got plenty of moving parts, as you can see on the screen. It's got plenty of moving parts, but the pivots are extremely simple. So hopefully, uh, if you use decent materials like a good hardwood, if you were using cane, then you would use perhaps a ready-made roller in between, okay, that you reduce the wear and tear on the wood, then basically the moving parts will go on for a much longer time. Remember, the load on each moving part is much less than when you have only two wheels or four wheels. like a car or a bicycle. Here you're talking about multiple. So you're spreading the load over a very large number of moving parts. And that means that the wear and tear on each part is much less.
Okay.
Uh,
So, sir,
Shiva?
there is a corresponding question in the chat box that a tire lasts for 4 to 5 years. How long would these legs last, given that the usage is same?
Yeah, it is. Now let's think of a tire. There's a huge expensive rubber thing. Before tubeless tires, there were two rubber things. There was an inner tube and an outer tube. Then you had to have a heavy cast hub to hold it. Then the center of the hub had a system of uh, very expensive bearings. Then you had to have brake pads. That's all part of what goes into a tire. Here, there's none of that, basically. So I think it's a much simpler. Here's a question. Can we make a prototype at IWSA? But I didn't know that IWSA has got a physical facility. If you have a physical facility, then certainly you can do this. It's
So,
really a very trivial project.
sir, we do participate in such things. This is Vijaya from Arunan's group, sir.
Hi, Vijaya. How
Vijaya
are you?
Tilak.
Good to actually talk to you.
Nice, sir. Thank you. So, actually, this is very interesting to me. I can make a small chaloped for IWSA garden where I can use it for various purposes. I'm just thinking about it. This idea
Yeah,
came to
that's not
me
a bad idea. It's really wonderful that you're thinking along these lines. And if
because,
I know that IWSA is somewhere at Vashi, so I don't know
yeah,
exactly where, but
yeah.
I live in Bandra, so it's not impossible to come
It's
there.
okay. You can come to Vashi or we can come to Homi Baba where you have worked for so many years.
No,
And,
but Homi Baba, I no longer go there, and the lab is closed down from there.
okay, our
So,
lab is open. Our lab is open.
right. Yeah,
Ours is a very
yeah,
primitive
yeah.
lab. You can do anything there.
Correct. And this is a very primitive device also. So it's designed to be primitive, it's designed not to need high technology.
Yeah. This idea came up because 4 5 years back we encouraged one small child in the 9th standard. Now he's an entrepreneur for controlling water supply in the village, erratic water
Yeah.
supply to the field. So he's doing that, and we are expecting him to come on 4th of October to IWSA.
Okay.
So maybe before that we can meet once. Wherever you want, we can come. 3 or 4
That's
of us. How
terrific.
to take the
I,
project
I,
up ahead?
yeah. What we can do is one of these days I can come to Vashi and sit down for half a day or one day and chalk out exactly to make a physical program
Yes.
and
Yes.
uh,
We would
make a
love it, sir.
think of what device want to make and go ahead, and run that project internally at IDA.
Yeah, that will be very nice of you. Thank you so much.
So, do we have any more questions?
First, have all the questions in the chat box been answered?
Yeah, I think so. There was one question which got missed out, which is what will power this?
Right. I had a
What
similar
power
one.
will we use? Yeah.
What are the power devices? So, of course, a bicycle is human powered. Okay, I think a small car would also be human powered because it's very lightweight. But if you're trying to carry a number of people with you, then of course you need additional power. So, one of the earliest designs that I had thought of in Chalopede was linear motors. Instead of using this device which is on screen, the purpose of this is when there's a horizontal movement, so I can't point to it, but the second horizontal bar is the moving device. Okay. So the upper bar is connected to the vehicle. The second bar is connected to the moving device. And the lower vertex is what moves up and down absolutely vertically. Okay, that's the design of this simple actuator. So what happens is that if you deliver power to the horizontal device, then the vertical device moves up and down. And the combination of these is what gives you the movement of an exaggerated ellipse, which is the movement that is most desirable, that Theo Jansen already worked out, most desirable for best movement across the ground with the least energy. So what power device could you use? I had thought of some years ago a very simple device using two linear motors at right angles and looked at what options there were for linear motors. Electric linear motors, as it turned out, were at that time quite expensive. Okay, at that time, actually, I wasn't even thinking of simple moving devices. I was thinking, let's make a vehicle which will compete with the what is it called, Formula Electric. You know, that's a race which is run once a year or twice a year, in which electric vehicles compete with Formula One type conditions. So these are high performance electric vehicles. Now, if you make a device with that kind of budget, okay, you start with very high quality linear motors. It's an extremely simple device. All you need is two linear motors fitted at right angles. You don't need the linkage that I've shown over here. You need just two linear motors at different devices. You need a controller which will control those linear motors, the motion of those linear motors. And you need an electric power source, which is, of course, what Formula Electric is designed for. They use a battery set, okay, a set of battery power cells in a battery set. So depends on what you want to do. If you want to make a high-speed vehicle, then actually you can make one that doesn't use wheels and is cheaper than your typical Formula Electric. It will have the same kind of speeds. I'd actually done some calculations some years ago and looked at what kind of uh, you know oscillation you needed of the motor, and we were talking about 10,000. Well, I don't know what they call it. It's not RPM, obviously, because there are no revolutions. It's a linear motor. So LPM, 10,000 LPM would give you speeds of 200, 250 kilometers on the ground. So pretty good speeds, I think. And it'd be really easy to make a vehicle in terms of the thing. Making the motor controller would be a different job because you'd want very high reliability for that motor controller. And you'd be having multiple such controllers, maybe 1,000 of them or whatever, in that kind of scale. And you'd have a vehicle which is actually something like a millipede, something like a centipede. So it's got multiple legs, extreme stability, extreme road holding ability at very high speed. It just would not fly off the road, which is a big problem with high speed cars. They tend to actually lift up into the air and fly off. This would not happen with legs.
So there is one more question in the chat box. It is framed as a question. We are trying to reach the circumference of the wheel using a system of movable straight lines. Are we?
That's correct. Yes, yes. I thought for a standard vehicle, which is the equivalent of a road vehicle, for some reason, when you look at modern cars, they use two standards: 15 centimeters for a a luxury car and 17 centimeters for a comfortable car. So that's the kind of distance you want. You want that much clearance from the ground. So that's the movement you want up and down also.
So if I've understood it correctly, your movable points can be controlled by a one-point power system.
Yes, it can be controlled by a one-point power, but it's not a one-point power system, no? Because it's a distributed power system because you're actually controlling the movement of each one individually.
Yeah, so
You're just consolidating them in a controller. But that's, by the way, it's called a collective, and that's how helicopters fly. So this is nothing new. Huh? Helicopters have been around for 100 years. Nothing new at all. It's all very old.
Okay, so do we have any more questions?
Seema ma'am, Kriti
Yeah.
has a question in the chat box. Sir, can we have any feature added so that people.
Oh, yeah. Yeah.
Sorry, I haven't
Yeah, read it
understood
out
the
to her,
question.
it's okay. Sir, can we have any feature added so that people with disabilities can use for movement? I think, yeah. Okay.
Absolutely. We just have to look at ideas that Cyberdyne does, for instance, and they already do this. These are assistive devices which help people with very severe motor problems, and they have computer aided controls which can be controlled either with the fingers, or they have eye control, or you can use your mouth to control to to guide the device. These are all practical things that have already been done. Of course, an assistive device is going to be much more expensive than a device which is designed for simple movement. We understand that because that's why assistive devices tend to have extra things built in to make it easier for the person to control. The whole purpose of assistive devices is to give a person agency, to return agency to the person. And you have to probably add some cost or some complexity to the device in order to ensure that the person has agency again. That agency was taken away by whatever damaged the legs or the spine or whatever. And we want to return that agency to the person.
Okay, sir. Thank you so much.
So we've
Okay,
actually,
so
I see here that we've actually moved to 6 o'clock. So do you want to close, or are there more questions? I'm here, so not a problem.
I don't see any more questions in the chat box. If anyone has to ask any more questions, please.
No, thank you, Seema.
Yeah, thank you, ma'am. So I think, Mr. Vikram, I think you took us on a path, and you started it like a story with, concerts at Ganga, which I have also attended a few when I first moved here, but now they got stopped. And then to the Nayana phonetic script, and then to the first technology using used by like using fire, then tool making, and then how it all changed when the wheel got made, and then when we had wheels, we had roads so that we could use the wheels, and how that changed the whole circumstances, and how roads actually started impacting us in the flow of water and the land, and then interfering with the forest. And then what are the alternatives to these wheels? And then you took us to what you are attempting to do now is the Chalopid project, which I will admit that I don't fully understand. But yes, it has been very nice having you here and making us aware that, things are being done, things like Chalopid's mission is on. And I would also like to thank on all our behalf Mr. Arun Mehta. I saw him, he's also here. So thank you so much, sir, for attending this. And Mr. Vikram, I hope you will help us, IWSA, to come up with a kind of a chalopid, as Vijaya has spoken to you just now. So we will, so our trustees will get in touch with you, sir, and we will have that meeting. And I hope we can go somewhere. You can, kind of handhold and take us somewhere. Thank you so much, sir, for
Most
being
welcome,
with us
most
today.
welcome. Thank you for the invitation. Thank you so
Yeah,
much.
thank you so much.
Thank
Thank
you
you
so
so much,
much.
sir. And now, Suparna, if you can request everybody to keep their videos on, maybe you can take a screenshot or something.
Maybe sir should stop sharing.
Yeah. Sir, if you could stop sharing, and if everybody could just keep their videos on for a second, we will just take a
I've
screenshot.
touched the machine. Yeah, there we are.
Yeah. Yeah. So nice to have you here, sir, today.
Thank you very much.
Only
It's really
hats, no
kind of you
topi.
to think, and I hope that you enjoyed it.
We
Yes.
enjoyed it.
Yes,
And
we
no
did.
more topis on us. No, you never